Okay, everybody, let's get started on section 2.1b. So we're still talking about frequency distribution tables. We made that one at the end of 2.1a. That really is a grouped frequency. So whenever you've got a big grouping of things. So we take our raw data, we group them up in equal classes so that we can see what's happening and look for maybe a trend or what the data looks like. So don't get confused because we've already done one. We're just going to get more into finding the classes and everything. So use a grouped frequency distribution when the range of quantitative data is large. We must group it into classes. This is how we can actually look at the data. The lower class limit is your smallest data value. So you always start with whatever your lowest value is. You need to find your upper class limit for each class. Remember, in 2.1a, when we found the class list, we added for the lower class limit, and then we filled in the upper class limit. So when I'm saying upper and lower class limit, if the class is from 6 to 17, 6 would be the lower class limit, 17 is the upper class limit. We need to talk about class boundaries. If you recall back in chapter 1, I'd say what would be the boundaries if we had 17 degrees Fahrenheit and it was 16.5 up to, but not including 17.5. So this is your midpoint of the above and the below class limits. It's what rounding would do if we had a number that needed to be rounded. We'll talk about these. It'll make more sense when we put them in there. So remember, hopefully, the class width is the difference between the lower class limit and the lower class limit to the lower class limit of the next. Important, because it's not that one class. 6 to 17, our next class would start at 18, so our class width would actually be 12. And the class midpoints I'll probably ask you to find. That's the average of the upper and lower class limits. It's the actual numeric location of that class. That seems weird. Let's fix that. All right, so all these are technical things. These are all going to be headings on our group frequency distribution, or our frequency table as I usually call them. So let's look at how you group them, some rules that you have to follow. So first of all, you should have somewhere between 5 and 20 classes. I told you in 2.1a, I will tell you how many classes to use. If I don't tell you, ask me. That's not something that's usually up in the air. 20 classes is a lot of classes. You have a huge range of data if you're going to use that many classes. It's preferable, but not necessary, to have a class width that's an odd number. The only reason is because mathematicians are lazy, and if you have an odd class width, then we get a midpoint that's a nice number. Classes must be mutually exclusive. We mentioned this the last time. You can't have data fall into 2 classes. You can't have an overlap of your data. Classes have to be continuous, so not only can you not have an overlap of your data, you can't skip a few in the middle. You can't have one class be 1 to 4 and the next class starts at 10 to 14. That won't work because they're not continuous. They're also not the same width of classes. There must be enough classes to accommodate all data values. You have to make sure that your classes work so that you get your smallest all the way up to your biggest. You can't just be like, I don't like that data value, so I'm just not going to include it. If you start out with a group of 30 raw data, you have to have 30 data in your frequency table. And last but not least, class widths must be equal. There is no option. You can't just change things up. Just like on a y-axis for a graph, you can't start counting by 2s and then switch to 3s later. You have to have everything equal. So let's construct a grouped frequency distribution, or as I'll call it, a frequency table. So I've got salaries of college and university coaches. We're going to create a frequency distribution. So the first thing we need to do is determine our classes and fill in our limits and boundaries and everything else. Then we're going to tally, right? We're going to use our tally marks, and we're going to find the frequency of each one. And then we're going to, like I just said, find our numerical, our raw data frequencies. And then we're going to calculate and talk about relative and cumulative frequencies. So there's a lot of things going on here. So let me scooch this up a little bit. So I've got a sample of 30 college and university coaches in the US. Construct a frequency distribution for the data using 8 classes. Notice I told you I will tell you how many classes I want. So 8 classes, so think back. Our first job is to figure out our highest and our smallest so we can figure out our range, and then we can figure out our class width. Also, I do want to say up here, when you do your relative frequencies, I'm going to ask you to keep those as decimals, not as percentages. So I'll say decimals, not percents. That's for, sorry, I forgot about that, our relative and cumulative frequencies. All right, so first thing we need to do is we need to do range over n, and that equals our class width. So our range, it looks to me like the highest value is what, 857? Is that right? 857. Smallest value looks like it's going to be a 140. So 857 minus 140 is going to be a grand total of 717. I'm going to divide that by, that shouldn't be n, fix that. That should be the number of classes. Man, I'm a mess today. Fix that, highlight it, don't forget it, because I just did. So range divided by the number of classes, I set up there in the directions, construct a frequency distribution using 8 classes, so divide that by 8. Hopefully you remember from last time, when you divide, it does not matter what you get as far as a decimal, you're going to round up no matter what. So when I do this math problem, I'm getting my calculator right now, 717 divided by 8 classes, 89.625. So my class width is going to be 80, or is going to be 90. So every time I do every class, remember from our lower class bound, our class limit to the next lower class limit, it's going to be 90. So then I take my lowest value. So my 140 is always going to be my starting point. I add 90 to it. That's my next lowest class limit. So 230. Then I add 90, add 90, add 90. It should work out where I'm going to fill all 8 of these. I made a little graph for you with 8 spots for our class. For our classes. So it's going to be 590, that's going to be 680, and 770. But I'm not done, right? That's just the lowest class limit. I need to go, that's going to go from this to this. So if 140 is my first lowest class limit, the next one starts at 230, this is going to have to go to 229 then, right? No overlap, but it's continuous. I don't have any decimals, so I don't have to do like 229 point something, because it's either going to fall into the 229 or into the 230. So this is going to be 319, 409. Does everybody see where these are coming from? 499. Notice in your upper class limits, those are also adding 90 every time. So, or back up one from what you had before. So 589. 679, 769. What's your final class limit going to be? 770 up to what? Our next one would start at 860. So this one has to be 859. Be careful on that last one. Don't make it a different width than all the others. So class boundaries are what is directly in between. If this one right here is 229 and this one right here is 230, I've got to have a 229 and a half. So I'm going to go a half a unit in between. That means that that starting one, which is always the trickiest one, is going to be a 139.5. So this one has to start at 229.5. Remember, it's non-inclusive. I would not include the 229.5 in the upper. It would round up all the time, but we're not using that inequality. So if this class ends at 319, the next one starts at 320. It's got to be 319.5. Repeat that. 409 to 410, so 409.5. Repeat that. 499 to 500, so 499.5. You getting the hang of this? Repeat. 589 to 590, so 589.5. Repeat. 679 to 680, 679.5. And 769 to 770, so 769.5. And last but not least, this is going to be half a unit bigger, so this is going to be 859.5. All right, I wanted to go through that. Midpoint, I think you're going to be able to figure this out pretty quickly. Midpoint is add your upper and your lower class limit, so 140 plus 229 divide by 2. That's going to be your class midpoint. So I believe that's a 184 and a half. Change colors, 184 and a half. So midpoint is equal to low and up limits divided by 2. It's a halfway point. It's the average of your two sides of your class limit. You can go through all of that. I want to jump over, so go ahead and figure out those class midpoints and start doing your tally marks. I'm going to hit pause. I'm going to take that and get that filled in, and then we can talk about the frequencies, the cumulative, relative, all that other stuff. All right, hopefully it was that quick to get all that data on there. Double check my midpoints. If my math is right, my midpoints should all be 90 apart as well, because that's my class width. So your class width is really going to come around and repeat itself often. So cumulative frequency. Cumulative is adding as you go. You're accumulating things. It's not a decimal, it's not a percentage, it's how many of the pieces of data have you had so far. By the way, I forgot to ask you if you double checked your frequencies. If I add all of those up, according to my information, I should have 30 pieces of data. Double check and make sure that you've got 30 pieces of data there. It looks to me, if I add everything up, I have got 30. So verify that, 16, 20, 28, 29, 30. So cumulative is adding. So at this point in my frequency distribution table, I've got 11 pieces of data. It's kind of like a bowling score. So I'm going to add this 5 onto there, and I have 16 pieces of data. I'm going to add the 4 there. I've now got 20 pieces of data. Add the 4 to that. I've got 24. Add the 4. I've got 28. Add 0. I'm stuck at 28. Add 1 more. I'm at 29. Add that last one. I have 30 pieces of data. So it's just a cumulative frequency. It's adding. Your number of pieces of data should be your final cumulative frequency. Relative frequency is frequency over n. So we have 30 pieces of data, so 11 out of 30 would give us a 0.367. I'm going to go out 3 decimal places. Notice I'm not turning this into a percentage. I'm leaving it as a proportion. When you do your relative frequency, skip back to plain old frequency over n. I don't want a relative cumulative frequency until I get into the next column. So I should have probably switched the order of these 2 columns, but I can, as long as I pay attention to the difference between them, This is just relative, so my original frequency. This is the cumulative relative. So I'm going to continue on. I'm going to do 5 divided by 30. Whoops. And this is a 0.167. I'm going to do 4 divided by 30. This would be a 0.133. Use your rounding rules. The only point that we're not rounding like normal, remember, is figuring out our class width. Always round up. So I keep going on. This would be a 0.133, 0.133. This is going to be a 0. This is going to be something tiny, like a 0.033 and a 0.033. If I add up all my relative frequencies, what should they all add up to? It should be 1 whole, or if you like to think in percentages, it should be 100%. Remember, we could be slightly off due to rounding. So cumulative frequency is the same concept. This is adding again, but it's adding our cumulative, or it's adding our relative frequencies. So I take this straight across, a 0.367. I add that on, and I get my next cumulative relative frequency. Oops, 0.367. So 0.534. And then I add that 0.133 on there, and I get a 0.667. And then I add that on there. I should get something super nice with that one. Like a 0.800 or a 0.8. Add that one on there, 0.933. I'm holding steady with a 0.933. Add that one on there, I've got a 0.966. Add that one on there, I've got a 0.999. So again, due to rounding, I'm at 0.999. That's about as close to 100% or 1 as I could get if I'm rounding things. So there's a lot of business going on here with this relative frequency table. It's easy, you just have to keep track of everything. And we talked about a ton of stuff. I know I got words everywhere on the board. So let's go to, how about if you do this one? So following data represents the number of bales of hay that were made in 40-acre fields across St. Clair County. So then I've got a bunch of stuff down here. I've got the data, find the class width, find the range. I'm telling you how to do everything. And then I've got a table. Please notice I ask you to do 7 classes. So I just left you a huge table. You can divide it up because I wanted you to have to read for that, but then I pointed it out. So I'm only asking for the tallies and the frequencies. I wish that I had asked for more than that, but that's all I did. However, I put a couple sneaky things in here. Find the relative frequency and find the class midpoints. So add in here midpoint and relative frequency. There's probably enough space to scooch those in there, right? So class limits, class boundaries. There we go. That should do it. So do that. Let's talk about it. Let's see how this goes. I gave you a lot of hints and then those directions, so keep me posted, and happy frequency tabling.